In this part, we take a deeper look at the physical quantity called friction. Friction is a force that opposes the relative motion or tendency of such motion between two surfaces in contact with each other. It is a fundamental and pervasive force in the physical world and plays a crucial role in various everyday phenomena and engineering applications. We recall the two types of friction: the static friction when the body is at rest and its behavior prevents the body from moving. The kinetic friction, which opposes the motion of the body that will result in slowing the motion of that same body. The coefficient of friction is a dimensionless number that represents the ratio of the force of friction between two objects in contact to the force pressing them together. It quantifies the stickiness or slipperiness of the interface between the two surfaces and provides information about how much friction can be expected in a particular situation. The coefficient of friction depends on various factors, including the nature and roughness of the surfaces in contact, the presence of lubricants or contaminants, and the normal force, the force pressing the two surfaces together. Different materials and surface conditions will have different values for their coefficients of friction. Static friction is typically greater than kinetic or sliding friction due to the nature of the contact between two surfaces. This difference in magnitude between static and kinetic friction arises from the microscopic interactions that occur at the surface of the objects in contact. Here are a few key reasons why static friction is greater than kinetic friction. Surface interactions: when two objects are at rest relative to each other, their microscopic irregularities or asperities on the surfaces can settle into each other, creating a temporary bond or interlocking effect. This makes it more difficult to initiate motion. The static frictional force opposes any external force applied to overcome this bonding and initiate motion. Energy considerations: it takes additional energy to break the initial bonds or overcome the resistance to motion between surfaces at rest. This energy requirement is not needed when the objects are already in motion, resulting in a lower kinetic frictional force. Constant sliding motion: once an object is in motion, the surfaces are effectively slipping or sliding past each other. The frictional forces in this state are generally less because the contact points are continually changing, and there is less opportunity for the interlocking effect seen in static friction. Temperature effects: in some cases, as an object starts moving, there can be local heating due to friction, which can further reduce the coefficient of kinetic friction. Here we have some coefficients of friction and they are determined experimentally. Here we see that the static value is greater or close to its kinetic counterpart. For wood on wood surface we see that it is around 0.25 to 0.5 for its static value. It is 0.2 for its kinetic value and it is of lower value. For rubber on wood, we see that it varies on the type of rubber. For hard rubber on a dry wood we see that it is 0.7 for its static value. We would expect that the kinetic friction would be lower than this. In addition to these two main coefficients, there are other specialized coefficients of friction for specific situations or materials, such as rolling friction coefficient. This coefficient applies to objects rolling, like wheels, on a surface and is different from kinetic and static friction coefficients. Fluid friction coefficient: in fluid dynamics, a coefficient of friction may be used to describe the resistance to motion between a solid object and a fluid such as air or water. Coulomb friction coefficient: this is a general term that can refer to both static and kinetic friction coefficients. Thank you and I hope you learned something new today. For questions and comments you may send them to diyeslearningstuff@gmail.com. You may review the slide on YouTube at @diyeslearningstuff. Note: please do not forget to use your school email, your name, and class section. Thank you for listening and see next module.